Take out your Unit 2 note packet and find 2.6, Rational and Irrational Numbers. Our standard is I can read, write, represent, identify, and compare rational numbers. The goal that goes with that standard is I can recognize the difference between rational numbers and irrational numbers. Really today, we're defining rational numbers and irrational numbers. You need a calculator, so if you don't have one, pause the video and go get one. I am going to give you 12 values. You need to change those 12 values into decimals and place them in the column that they fit with. For example, if when you change the fraction or when you change the value to a decimal, the decimal stops, it terminates, you're going to place the original value and the decimal in the first column. If when you change the value that I'm going to give you in just a moment to a decimal, you would have to use a notation bar because a digit or groups of digits repeat, then you're going to place the original value and the decimal with the notation bar in the second column. If when you take the value and you change it to a decimal and you can't see a pattern of a digit or groups of digits that repeat, you're going to place the original value and let's round the decimals to the nearest hundredths place here. I'll give you an example. So here are the first three values. I want to go to this third one right here. I want to change this to a decimal so that I can place it in one of the according columns. Using your calculator, this is a letter of the Greek alphabet. We refer to that letter as pi. It is what a lot of mathematicians have worked with. It's so popular that our calculator has a key just for it. Take out your calculator and let's make sure that we're on the right mode. So if you click mode, make sure that classic is flashing and you'll click enter and then clear. Find the pi button. It should look really similar to mine. I'm circling it here with my cursor. If you click that and click enter, you'll see you get a decimal. Now, this decimal doesn't have any digits that repeat or a digit that repeats, so I'm going to round this decimal to the nearest hundredths place. The 4 is in the hundredths place. If I look next door, I'm just going to keep this a 4. So pi is about 3.14. So you'd put the pi symbol here where my cursor is, about your squiggly equal sign, 3.14. It is a value that when you change it to a decimal, it doesn't have a pattern to it. So again, like I said, I have 12 values for you to change to a decimal and place in the appropriate column. Go ahead, pause the video, and do that now. Check your answers with mine. In the terminating decimal column, you should have, not in this particular order, 7/8, which is equal to 875 thousandths as a decimal. See how it stops? The square root of 81, which when you simplify that, you get 9. 3/4, which as a decimal is 75 hundredths. And the whole number 5. You can write whole numbers as decimals, right? It's just the decimal point is normally invisible, right? It's right to the right of the 5 or right to the right of the 9. Change anything you need to in your first column right now. For repeating decimals, 7/22, you should have 0.318 with a notation bar over the 1 and 8. Those are the two digits that repeat on forever. 4/9 is 4/10 repeating. 5/6 is 0.83 with the notation bar over just the 3. 3 and 5/11, 45 hundredths repeating. So these decimals, whatever the notation bar is over, those digits or the digit is going to repeat forever. We call them repeating decimals. These are the values out of the 12 that I gave you that have no pattern to their decimals. The first one I did with you was pi. And right over this symbol, you can write the letters P-I. That is pi. It is about, that's why we use the approximate sign there, the squiggly equal sign, 3.14. The square root of 34, it didn't have a pattern to the digits, so it's about 5 and 83 hundredths. Square root of 2 is about 1 and 41 hundredths. Square root of 15 is about 3 and 87 hundredths. Now, do you see my fancy brackets? Terminating decimals and repeating decimals, the values that give us those, they have a special name. They're called rational numbers. You've heard that term before, haven't you? Numbers that don't have a pattern to their decimals or to the decimal form of them, we call irrational numbers. Let's break that down a little bit more. So rationals are, fill this in your notes, made by dividing two integers. And you might go, what, Mrs. Clover? Back that up. 7 and 8, those are two integers, right? 7 divided by 8. 9 was my answer for the square root of 81. That's a rational number because I could take it and go 9 divided by 1. 75 hundredths here, I could take it and go 75 divided by 100. How you read it is how you write it. Rational numbers are formed by dividing two integers, or they're your numbers that in decimal form terminate or repeat. So you need to fill in made by dividing two integers. Rationals also terminate, like I already talked about, and they also repeat. So repeat, repeat, repeat. Rational numbers are any type of number that when you change them to a decimal, the decimal stops or the decimal repeats. Remember, whole numbers can be written as a decimal. The decimal point is just normally invisible with whole numbers. Let's look at this in a little bit more of an advanced way. Calculate with rational and irrational numbers. Is the result rational or irrational? Find the next part in your notes titled Calculating with Rational and Irrational Numbers. So now we're going to calculate with them and see what our answer is. Is our answer rational or irrational? So that's what we're going to decide. Look at the first expression, 1/2 times the square root of 64. Now, whenever we have multiple operators going on, we got to use order of operations. I'm seeing grouping symbols, so we're going to start with that square root of 64, which is 8, and half of 8 is 4. Each one of the values in this expression is a rational number, right? A rational number is where you take an integer and you divide it by another integer, where you get a decimal and it stops or repeats. 1/2 is a rational number, and the square root of 64 gives you a rational number. So this is going to be a rational number. 4 is created by dividing two integers. Look at the next expression, 6 plus the square root of 25. The square root of 25 is 5. 6 plus 5 is 11. Can you create 11 by dividing two integers? Yeah. Does 11 represent a decimal that terminates? It sure does. Last one, the square root of 144 divided by 3. The square root of 144 is 12. 12 divided by 3 is 4. And we already talked above how 4 is a rational number. So each part of our expression actually was a rational number. That plays into whether our answer is a rational number or not. Anytime, fill this in your notes, anytime you add, subtract, multiply, divide by a rational number, you're going to get a rational number. And that's what I was describing as we were completing the 3 problems above. Look at the other 3 problems here over on the right-hand side. Make sure you have your calculator handy. And we're going to take pi and divide it by 2. So pi divided by 2. This decimal, does it repeat? Does it stop? No, we have to round. We'll round to the nearest hundredths. It's about 1 and 57 hundredths. We know pi is irrational, right? In our notes, it was under the irrational column there. Divided by 2, we know 2 is a rational number. To get about 1.57, and this decimal right here did not stop, it did not repeat. It is irrational. Let's do the next one. The square root of 15, let's type that in. Hit enter, now take away 1. We would round to the nearest hundredths because this decimal doesn't stop and it doesn't have any repeating parts to it. So 2 and 87 hundredths is about the value of this expression. The square root of 15 is an irrational number, right? It was in our irrational number column. Minus 1. 1 is a rational number, but since we took 1 away from an irrational number, our answer is also irrational. Look at the last one, the square root of 50 times 2. So let's type that in our calculator. The square root of 50, hit enter, times 2. You don't want 2 to be part of the square root up there, so that's why I said hit enter. I get 14.142135562. Is there any pattern to this decimal? No. Does it stop? No. So we're going to have to round about 14 and 14 hundredths. When you have an irrational number and you're working with it in an expression, it is affecting your final answer. It's making the final answer irrational. So anytime you add, subtract, multiply, divide by an irrational number, you're going to get an irrational answer. Make sure that is filled in your notes. Let's bring this to a close here. Rational and irrational numbers. Let's summarize here. Fill in what is in red in your notes. Rational numbers. Do you see how the word ratio is in there? Can be written as a ratio. A ratio is a division problem of two integers, giving you could get a whole number as an answer, you can get a repeating decimal as an answer, you can get a terminating decimal, a decimal that stops as an answer. If the number is irrational, it's icky. That's not a very professional way to say it. The professional way to say it would be when you are dividing values or working with values, your final answer, if it doesn't terminate or there's no repeating parts to it, it goes on forever, just digits, and there's no pattern to it, we call it irrational. Sometimes they're not as friendly to work with. Once you double check that your notes are all filled out and you have some good examples of what rational numbers are and irrational numbers, go ahead and find your 2.6 assignment in Schoology. A little change up. It is not in backpacks this time. You will not use the worksheet that is in your worksheet packet. You will use the assignment that is in Schoology, titled 2.6 Rational and Irrational Numbers Assignment.